Okay, so now we're talking about this idea of transformation, and we're going to talk about horizontal stretches and shrinks, and then vertical stretches and shrinks. So observe very carefully here. It says the graph of y equals f of a and x. And so there's been something kind of inserted here, and that's the a. But if you have this, it's a horizontal stretch or shrink. And so what is this a? Well, the a, it could be any number. It can be a whole number, or it can be a fraction, right? So if it was a whole number, the a could be like a 3. Or if it was a fraction, it could be a 1 over 2, right? But something's being put next to the x, which is the input. Something's influencing the input. We don't know what it is yet. It could be either one of these. But something's influencing the input, and we'll call that a. But when you influence the input, it has an effect on the line. And it's going to either do something we call stretch the line or shrink the line. Okay, and if it's the input that's being influenced, we call it a horizontal stretch or shrink. I'll show you why in just a second. But, not to be outdone, the output can also be influenced by an A. Notice it's not inside, it's not the x that's being influenced now, it's the f of x, the whole y. So, because remember that f of x equals y. So you can also multiply the y by a number, and that number can either be a whole number or a fraction. So the output can also be influenced, and that will also cause a shrinkage or a stretch of the vertical axis. So it's the input and the output that can be influenced here. Cool, the output. So let me show you what it looks like real quick, and then we'll go into more detail. So I went ahead and graphed a line, and let me take this green spaghetti. Don't ask me why it's green, it just is. And so if I were to get a number, that a would be greater than 1 on the input. Again, that's inside the x. So let's say it's a number greater than 1. Let's say I want to use, doesn't really matter. Let's say I have something like f of x equals, and then I have a 2 times the x. So that where the a was, and now putting a 2. That's going to influence my line. That's going to change it, right? And so if you have a number greater than 1, what you see that starts to happen is a shift of the line. And it says that it shrinks. So what does it mean that it shrinks? Well, on the y-axis, it still stays on the y-axis, but it starts to shrink away oh, I'm sorry, going the wrong way. It starts to shrink away. Shrinking would go this way from the horizontal line. It's like it's afraid, so it's shrinking in fear. It's going away. Do you see how this line is shrinking away from this horizontal line? It's moving along the y-axis. That's its pivot point. The line starts to shrink away when the number is greater than 1. Okay. But then you have this thing called a stretch that can also happen. And so if it were like a 1 over 3 inside, so instead of it being like f of x equals 2 times x, if the input was a fraction, so like f of x equals a 1 over 3x. Well, that would also influence this line. It would change it. And which direction would it go? Well, it would still pivot along the y-axis, but it would start to stretch towards. See how this top here is reaching towards the x, the horizontal line? And over here it's reaching towards the horizontal line. So it would be called a horizontal stretch, as it's not shrinking in fear, but stretching out to it. So that's what a horizontal shrink and stretch is about, and that's the numbers that would cause that. Likewise, though, you can not just have a horizontal, but you can have a vertical stretch and shrink. So instead of it rotating on the y-axis, like as the pivot point, the x-axis is the pivot point. You still do a rotation, and instead of it stretching with a fraction now, it's stretching with the whole number. So if the whole number is greater than 1, which would look something like, now remember, we're dealing with the outputs now. So let me just write something quickly. If we had something like 3f of x. Notice the input's not being changed, but the f of x is being multiplied by 3, right? It's being multiplied by a number greater than 1. And so it's going to stretch this line towards, let's see if I can get it over there. So this line's still going to pivot from this point now, but it's going to be a vertical stretch. So it's going to stretch towards the vertical line. See how it's going closer to the straw. Move this paper out of the way, how rude, right? And see how it's pivoting towards the vertical, the line, the y-axis that's going up and down. Okay, so that would be a stretch if it's greater than 1. But then if it was less than 1, if it was a fraction, it would still pivot at the x-axis, but it would shrink away from this line, so it would be a shrinkage. Woo! Okay, so this is just the concepts. We haven't done any math yet. It's just the ideas behind what when we call something a vertical or horizontal stretch or shrink, and kind of the cause or the reason it would stretch or shrink. Let me show an example. Let's do one of a problem here. It says, let f of x, which is the same thing as a y, it's just in function notation, equal x minus 1. So the b would be a negative 1, the m would be a 1 over 1, so I went ahead and graphed the line already. And then it wants us to do this transformation. It says let g of x equal this f of x, but with a 1/3 of the x. So 1/3 of it. So this is a change in the input. See how it's next to the x? So you're changing the input. So you can look at the cheat sheet and see which way a fraction goes. Is that going to be a stretch, or is it going to be a shrinkage of the horizontal horizontal stretch or shrinkage? One way, though, to be able to actually do this practically and see where the line should be is to go ahead and multiply it by the 1/3. Multiply the x by 1/3. So as you can see, I put multiples of 3 in here so that the math is really simple. So 1/3 of a negative 1, or negative 3, would be negative 1. 1/3 times 0, put the 0 for the x, would be 0. 1/3 of 3 would be 1. Okay, so now, when the line is at a negative 1, when the x is at a negative 1, what would the new y be? So if x is at a negative 1, what would the new y be? Well, the y would be at when the x is at a negative 1, the y is at 2, negative 2. If the x were at 0, what would the y be? Well, if the x were at 0, the y would be a negative 1. You can see when the y is at 0, the x is at negative 1. And when the x is at 1, the y is at 0. So this is the answer, but then how does that actually transform the line, right? How would that actually move the line in that case? Well, you just move it to those new points. Remember, when you're rotating it, to keep it on the axis point. So I'd actually need to keep it on the axis point there, which is right here. Oh, and I can see we're running out of time. Well, that's no fun. Okay, well, that is the start of this lesson.